Good morning. So in the previous classes we have seen all the conversions, and in this today's class we will see binary arithmetics, nothing but we will see addition, subtraction, multiplication and division, those are in binary. Okay. Then we will see, if time permits, we will see 1's complement and 2's complement. So the objectives of this session are perform the following arithmetic binary operations such as binary addition, subtraction, binary multiplication and binary division. Okay. So after completing all this 4 with one example each, we will see 1's complement and 2's complement of a binary number. So first we will see binary addition. So whenever you are doing an addition in your decimal, you generally add your decimal numbers, and in this binary addition you have in binary only 0 and 1, only these 2 bits. So using these 2 bits you can form 4 combinations. Those 4 combinations are, the first combination will be 0 and 0, the second combination will be 0 1, third combination will be 1 and 0, and fourth combination will be 1 and 1. Okay. So in this binary addition, what all you need to do is just add them. Okay. I just want to see the result. When if I add this 0 and 0, I will get 0 plus 0, my result will be 0. Okay. And binary addition of 0 plus 1 means the result is 1. Whenever I add 0 with 1, I get 1. Okay. And 1 with 0, I get a same, that is 1. Okay. I am adding binary 1 with binary 0 here as it has shown. Next, when I am adding 1 plus 1. Okay. So when I add 1 plus 1, the result what I get is here 0 with carry 1. Okay, there will be a carry over here. So with carry 1, that is what he had shown here. In the sense, yeah. So whenever you are adding say a number 9 plus 3 1 2 and 9 2, if in case if you are adding this, so 9 plus these are decimal numbers what I am adding. The number what you write here will be 9 plus 3, that means 12 you get. So you write here 2 and you will write a carry over here 1. Okay. Then you will add 2 plus 1 plus 1, that means you will get 4. After that you add 9 plus 2, you get 10. So in general, in case if you have any other numbers this side, you write 0 and you will add a carry over here. Okay. And if you do not have any numbers towards your left side, then you directly write 1042. Okay. This is what you do. So same goes with this binary number, but here all you have is zeros and ones. Whenever you add 0 0, the result will be 0. When you add 0 and 1, 0 plus 1, you get 1. 1 plus 0 also 1. But when you add 1 and 1, always remember 1 plus 1. Okay. When you add 1 plus 1, the result will be 0 with a carry 1. Okay. Carry is mentioned here. Is that fine? So generally, to know in more detail about this carry, if you do further the next extension of this subject in your programmings, you will have a flag, carry flag. Generally this represent over there. Generally where do you use this binary numbers? In your machine level language, right, for programming. So there, to store a carry, you have a register, generally that is called a program status word or flag register. Okay. In different programmings in different orientation way, generally overall we call it as status because it shows the status after addition. Do you have any carry or do you have any borrow, in that way. So generally this carry is been over there, and later if you want to add something else, then that carry is taken and it is added with that so and so number. Okay, so yeah, I will not go into that, you will be confused. So for now you need to know is binary addition. When you add 1 plus 1, always the result is 0. No, the result won't be 1. Okay, the result is 0 but with carry 1. Okay, you get this. So because when you write a carry over here, you don't have any number here to add, that means it is 0. So 0 plus 1 is something but 1. Is that fine? So for example, I will do a small example here with this carry by taking this carry. Yeah, let me write 0 1 1 1 1 1 0 1 1 1. Okay, yeah, when I do this, see, when I add 0 plus 1 I get 1. Okay, see, 0 plus 1 addition, I am doing binary addition. 1 plus 1 is 0 with a carry 1. Okay, I have the other number to my left side, so I am adding this carry to that. Next, see, 1 plus 1 means I get 0. I mean, I shouldn't write here because I have a carry to add for it. Okay, so 1 plus 1 is 0 with carry 1. Carry is going to the left side because 1 plus 1 is 0 with also carry 1. So carry I have written here. Again, for this result I need to add this carry as well. So 0 plus 1 I got 1. So 1 plus 1 plus 1 is always 1 with a carry 1. Okay, if you get confused that way, just do it in this format. First add this 2 ones, then you will get a result, that is 0 with carry 1. Okay, and this result should be added with this carry which you got from the previous number. So the answer is 0. Next, so you shouldn't write all this. Yeah, next you have is here first 0 plus 1. The answer is, whenever you add 0 plus 1, 1. So with 1 plus you have a carry as well. So 1 plus 1, what you get is 0 carry 1. Is that fine? And now this 1 plus 1 you get 0 with a carry 1. Sorry, here the result shouldn't be 0 because 1 plus 1 is 0 with a carry 1 here. Okay, this is carry here, and here you also have this 1. You need to add this 1 to this 0. So 1 plus 0 you will get 1. Okay, so this carry, if you don't have some other number here to add it, so take 0 if you don't have. So that means you get 1. So this will be a binary addition. Okay, when you get a carry. Same way for subtraction, but you will borrow from the other number, same like how you do in your decimal. It is in that way. So we will see an example on this. See, 2 n-bit values we have taken, that is 1100, 1110. Add individual bits, propagate carries. See here 0 0 1 1 and the other bit is 0 1 1 1. Okay, 4 bits. In case if the one bit is 5 bits, one bit is 4 bits, then you know what to do. Just add zeros to your left side. Okay, how many ever bits are missing, that many you add zeros to your left side if it is integer part. Yeah. So when you add 0 plus 0, so 0 plus 0 you know it is 0, 0 plus 1 it is 1, 1 plus 1 you already know it is 0 plus carry 1, and when you have 3 ones you always get 1 with carry 1. So this will be a result 1 1 0 1 0. Okay, so we will see the result. See, 0 plus 0 he added 0, and he also mentioned here 0 because there is no carry, I mean carry is 0. So that carry he mentioned towards the left side. Next again, after that these two numbers he added 0 plus 1, that means you will get 1, and after getting the result you need to check if you have a carry or not. Definitely you don't have a carry because the carry was 0 from the previous addition. So the answer is 1. After that the carry, again you didn't get any carry here, so he has written 0. So no need of mentioning every time that 0, because if you write 0 or if you don't write any carry, that doesn't matter, but if you have a carry 1 then you need to write. Yeah. Next 1 plus 1 is added. Now when you add 1 plus 1 you will get 0 and it generates a carry. That carry is given to the left side of your other number. Now all these 3 if you add, you will get 1 with a carry 1. Is that fine? So generally in this way you do your binary addition. See, he has given the other number, so try doing this as well. We will try to do this. So here 0 plus 0, yeah, see 0 plus 0. So you got 0 as a carry, so result as 0. Next 0 plus 1, that is you will get 1. No, why did you get 0? There is some fault here, right? Let me check. See, here they have given you the wrong thing. Okay, here the result what you get will be 1. Here you will get 1 because 0 plus 0 0, 0 plus 1 you got 1, then 1 plus 0 1, correct, then 1 plus 0 0 with carry 1, and this is okay. So the result is 1 1 0 1 1 0. This is your result whenever you add 1 1 1 0 0, and when you add this you should get this result. Okay, here you get 0 when here you will be getting 0 if your question here is 1 and 1. Okay, because 1 and 1 means the result will be 0 with carry 1 here, then 1 plus 1 0 with carry 1. Okay, then 1 plus 1 0 with carry 1. So here you will get 1 with carry 1. So nothing but you already have a carry here. So then your result will be 1 1 1 0 0 0. Okay, just by changing 2 1s here instead of zeros, your result will change. Is that fine? So try to make this correction. Don't copy as it is. If you understand the concept, then try to solve it on your own. See, in this bit he did that because I said you will have a register separate for a carry too. So in this he considered a carry here. That means after, even though you are adding here 0 and 0, you had a carry. He considered a carry from carry flag. Okay, carry bit. That is the reason here he got if you consider a carry, then you definitely need to add a carry at your LSB. Okay, in the first itself if you consider a carry, so you should add a carry. See, even he solved here, once he did, and he got the same answer what we got before. Okay, I mean whatever I have written while solving with this red ink. Okay, so he corrected over there. Next, binary subtraction. So in this binary subtraction you have 0 minus 0. Okay, you get result as 0. 1 minus 0, you get 0. Next, 1 minus 1. Okay, so 0 minus 1 we will see later. Okay, this is the last option here he has given. So you know 0 minus 0, 0 is fine. 1 minus 0, okay, bigger minus smaller, then that is here you need to get one. not 0. Even here there is a mistake. Okay, there are lots of mistakes in this. Please correct it. This is 1. Okay, 1 minus 0 is 1, not 0. So here 0 minus 0 is 0, 1 minus 0 is 1, 1 minus 1 is 0. Now coming to 0 minus 1 is nothing but, see, you subtract 0 minus 1 in this binary? You don't have a negative symbol to write in a binary. I'm talking about, you can write negative numbers in binary, but you don't have more symbols. You have only two symbols, 0 and 1. Okay, decimal negative number you can convert that. So see, you can't generally, when your decimal, whenever you're trying to subtract a smaller number from a larger number from a smaller number, what you do is you go to the beside number and you take a borrow from that. Okay, you borrow that. So same thing what we are doing is, this one is we are borrowing. Okay, this is borrow. So we borrow and then that will become a larger number compared to this. Then if you subtract, then you get 1. Is that fine? That is what the explanation of this. So whenever you write this 0 minus 1, okay, that means always the result will be 1, because you will always borrow from your the left number. If you don't have anything, you generally whenever you have a carry or borrow, your carry flag in your status register, you consider it from there. Okay, so leave about that status flag now. Remember that 0 minus 0 is 0, 1 minus 0 is 1, 1 minus 1 is 0. It's like simple subtraction, right? It's nothing like to remember it. Okay, if you see, you'll get to know 0 minus 0, you'll get 0, 1 minus 0, you'll get 1. Okay, you're subtracting 0 from 1, so you'll get 1. 1 minus 1 means you'll get 0, and 0 minus 1 means smaller, larger number you're subtracting from this smaller number. So you need to take a borrow here. So you'll have a borrow from your left number, and then see, you have an example on that. Once you see this, you'll have a clarity on that. See, subtract column by column. So in this, see here, this is 1 minus 0. 1 minus 0 means the result is 0. Okay, this is fine. Next, 0 minus 1. So can you subtract 0 minus 1? No. So whenever you get a 0 minus 1, you just from this borrow from here. This 1 will become 0 here, and that 1 you will borrow here. Okay, so this will become 10 minus 1, you get 1. Is that fine? Whenever you borrow 0 minus 1, result always will be 1, because you will borrow from the next, or else from a borrow flag. Yeah, so after this, here you have 0 now. This one we just borrowed. Okay, this one. So you have 0 here. 0 minus 0, you get 0. Next, 1 minus 1, you got 0. Okay, so in this way we do subtraction. Next, the topic is, the binary multiplication. So binary multiplication, even this is very easy. Whenever you multiply with 0, always your answer will be 0. So 0 into 0 is 0. 0 into 1, you get 0. 1 into 0, you get 0. Is that fine? In all the cases, if you multiply with 0, you got result as 0 itself. And 1 into 1, you get 1. So this is your binary multiplication. So even for this, we have an example. 2 n-bit values as with decimal values. Okay. So n-bit means how many bits are we taking here? 4. Yeah, 4 bits and 4 bits. We are multiplying this. Is that fine? So when we multiply that, see, what we do is normal multiplication. How we do? Same you apply here. Okay. So if you do 1 or 2 examples on your own, you'll easily understand this. see first this 1 is there here. 1 with 1 you will multiply all this and that you will write here. The next case you will multiply with this one. Okay. So now this was done. The second one with this you multiply, and generally in your normal multiplication you will write it from here. Okay, you will leave this space here and you will start write it from here. Then again you will multiply with 0. Okay, then you will write that value here. Then multiply with 1 and write that value here. After writing all that, just add everything. See, under this you don't have any value. If you don't have anything, just add whatever you have. That if you don't have anything, that means those all are zeros. Okay, so no need to mention those zeros. Directly add whatever you have in that column. Is that right? That is what the subtraction method even in this by multiplication. So let's see. See, this is uh, first you need to multiply with 1, right? This 1 you need to multiply with this complete binary bits. So 1 into 0 is 0, 1 into 1 is 1, 1, 1. Okay, 1 into whatever you do as it is you get here. Next you are multiplying it with again other one. So that means again if you multiply with other one, you get as it is again, same. Okay, so again 0, 1, 1, 1. Now we are multiplying with 0. So when you are multiplying this with 0, see this with this 0, when you are multiplying 0 into whatever you do, you will always get all result as 0 itself. So you got all zeros here. Okay. Then again you are multiplying with this 1 into 1, 1, 1, 0. So you will get as it is number again. Okay. See you got. Now what you need to do is add them. Addition is exactly like a binary addition. So what you do, see here you have 0. Next here you have 1 plus 0. So 1. Okay, binary addition what we have done in the first case. Next 1 plus 1 means 0 plus 1 carry here. Okay, next 1 plus 1 plus 1 means 1 with 1 carry over here. Okay, next 1 plus 1 plus 1. Yeah, is this in this column itself? Oh, yeah. So 3 ones again in this column. That means 1 plus with carry 1. Okay. Then 2 ones is 0 with carry 1. Again 1 plus 1 is 0 with carry 1. So when you do this overall your answer you get 1 0 0 1 1 0 1 0. This will be your answer. Okay. So hope what I did was correct. Just check if it is correct or not. 1 0 0 1 1 0 0. Yes. Okay, so there's no mistake. So generally while doing, if we have lack of practice on this, we might make a small mistakes because you will have lots of ones and zeros, so you will get confused. Okay, instead of 1 you will by mistake you will just take 0 and you will leave us 1 bit somewhere, so you will get a wrong result. By that you will get a wrong answer. So that's what we need to correct ourselves by practicing. This subject is very easy but needs lots of practice for further topics. Yeah, this is another example. See, multiply 1 0 1 1 by 101. So with 101 you multiply this value 1011. So just multiply like I said, same way. Here 3101 means you will get 3 rows here. After multiplying, those 3 rows need to be added. Okay. See, what did he mention here is, if you are multiplying this 1011 with 101, he mentioned each step here. First you will multiply this one. This is called LSB. This is called MSB, right? So with LSB you'll multiply all this and you'll write here. After that you'll multiply with this 0, all this, and definitely you'll get all zeros, 4 zeros. Okay, next with this one you'll multiply. See, when you multiply with one, you should get as it is. Okay, when you multiply with this one, again this one is nothing but your MSB. So when you multiply again you'll get 1 1 0 1. After getting, you just need to add everything. Is that fine? That is what you need to follow. So here he mentioned that this 1 0 1 1 multiplying sorry, this is the solution. This is the sum what you have already done. What you are doing in this step, he mentioned. In this step you are multiplying this 1 0 1 1 by LSB, that is 1. In this step you are multiplying this 1 0 1 1 with 0th bit. Okay, he has written it in a statement form here. Whatever you are doing, whatever we discussed orally and we did in the previous, same thing he has done here. So see here again he is multiplying with MSB. Okay, so in previous sum we had 4 bits, so we didn't mention multiplying with LSB and MSB. This is not required to write. If you write this and when you write the result, if you get a correct result, then that is enough. No need of writing all this. Okay, if you understand, it is enough. If you can't understand, then it is better you write it so that you will not forget. Yeah, so after multiplication, now addition. So addition, if you do first 1, you will get 1. Try to do it on your own. Okay, 1, again 1 plus 0 you will get 1, 0 0 1 you will get 1, 1 plus 1 you will get 0, 1 carry 1 1. Okay, that means 1 1 0 1 1. Is that what the one I missed here? So 1 2 3 4 5. You need to get 6. Yeah, 1 1 0 1 1. So this is what you should get. Let's check. 1 1 0 1 1 1. After multiplying all this, we are adding all together. Okay, is that fine? Yeah, I see all this we are doing it in binary form. Okay, so here for verification he converted that binary terms into decimal and he verified it. Okay, same way we can also do it with your addition, subtraction as well as division also. Okay, that doesn't matter, but in your books they'll ask you, I mean in your syllabus, when they ask you for binary addition or binary subtraction, you should always do only this binary procedure itself. This they won't give any marks for this. This is only for your verification purpose. After doing all this, just to confirm it, it will hardly take some time. Okay, few seconds of your time. So just convert this and just check if it is correct or not. If it is correct, I mean convert after you getting a result, convert that to binary and check if this and this answer is correct. Then this is correct. Okay, same way you can check for binary subtraction, addition, division. So generally for smaller things it is not necessary, because if you practice, generally mistakes won't happen. But if you get a bigger numbers, then there it is better you cross verify it. And for competitive exams, it is better if you don't do all this. Instead you directly do whatever shortcut method you are doing. Okay, directly convert them to decimal and multiply, or whatever you feel good, you are comfortable with, because in the end all we need is only answer. In competitive exams they won't check for procedures, but in your end examination you should always follow these procedures, each and every line. Next we have binary division. Binary division is familiar to us, decimal division. So even this is like normal same division. Okay, you will get a quotient, remainder. Okay, so dividend, divisor, we already know all this. Yeah, now this see how will we do this is, first see 1 1. So 1 1 means here you have greater number, that is 1 1 1 1. Definitely this is greater than this. So 1 are 1 and 1. So in division what you do, you will subtract. So 1 minus 1 0 0. So now to divide with this in your divisor you have 1 1 and here you got 0 0, so which is lesser. So when this is lesser, just bring down 1 1 here. Okay, so even now what is happening, this is smaller. Okay, 0 1. When this is smaller, you just put it as 0 here. Is that fine? So 0 means next even this is not divisible because this number is smaller than 1 1. 0 1 is smaller than 1 1. So I need one more 1 here. I mean I need to bring down another 1 from here. So I'll get another 1, then I'll get 1 and 1. Is that fine? So when I brought 1 and 1, now 1 and 1 1 and 1. So 1s are 1 and 1. So now when I subtract this, I'll get 0 and 0. So now my remainder is 0, quotient is 1 0 1. So this is how I do. Is that fine? It is exactly like the same division. Okay, decimal number by seeing itself will identify which is bigger and which is smaller. Same way, even this, by seeing the number of bits, you can easily identify which is smaller and which is bigger by seeing zeros and ones. Okay, and in that way you see how is it divisible. So see, same thing what they have done is, see, ones are 1 1. Okay, and they subtracted. So when they subtracted, see here, that means this 1 and 1 minus 1 0, this 1 minus 1 0. He brought down this one, not that one, this just beside LSB, left to LSB. He brought that one down. So now the even that is not divisible. So when that is not divisible, in quotient you write 0. Okay, because that is not divisible. So generally after writing 0, no need of writing this 0 again here, because generally what he has done is each and every step clearly he mentioned in this slide. That means, see, this 1 1 into 0, we get 0, right? 0 0. So he wrote that, again he added, so you will get here 1. So again he brought this 1 down, then he wrote 1 here. Okay, in this way he has done. So instead you can just skip this step, not required, right, to show this it is divisible by 0 as well. So both the ways, whatever you are comfortable, you just do that. Yeah, so you got 1, and he also brought this LSB 1, whatever you have in your dividend, that LSB 1 value, that also he brought down. After that now you have 1 1. So now this 1 1 divisor 1 1 is divisible by 1. Okay, I mean ones are 1 1. Now you got 1 1, remainder you will get as 0, and quotient is 1 0 1. Okay, so in this way we do division. So for verification he has done 15 by 3, that is equal to 5. So you already know how to convert them. When you know, it is easy to verify. Okay. Yes, so for now we have seen the binary addition, binary subtraction, binary multiplication and binary division. Okay, so now representation of binary numbers, we have 3. Okay, one is sign magnitude form, one is 1's complement and 2's complement representation. Is that fine? So sign magnitude form, see here we have MSB represents sign, remaining bits represent magnitude. I mean what is that digit is what that number is. Okay, so see, when 0 means it represents positive value. When you have some number, how many bits of number is this? 1 2 3 4 5, 5 bits of number. If in case if you take 5 bits of number, in this is MSB and this is LSB, right? So this MSB represents this number is negative number or positive number. If you have 1, that means this is negative number, and the magnitude of this number will be remaining MSB, the remaining bits will be magnitude. Okay, so this number represents whether it is positive or negative. If you have MSB as 0, that is positive number. Okay, here he has written. If you have MSB as 1, then that is negative number. Is that fine? So in see, for example, he has taken 6-bit sign magnitude representation. 6-bit sign magnitude representation means, see, if he mentions this sign magnitude representation in this 6 bits means 1 bit, that is MSB, is gone for this to say whether it is the number is positive or negative. Okay, to represent the sign value, that is gone. So remaining how many bits are left over? 5 bits are left over. So now the remaining out of the 6 bits, 1 bit is for sign and other 5 bits is to represent your magnitude of your number. Okay, see, for example, he has represented plus 5 and minus 5. So you already know 5, we write 5 as, that means in terms of 6 bits you need to write 5. So first of all, if you take 1, 2, 4, 8, 5 means you'll write 4 plus 1, 5. So 0, 0. This is the value for 5. Okay, 0, 1, 0, 1. But here it is 6 bit. 6 bit means I just want to add 2 more bits here. Okay, so I am saying only 5 bits I am taking as a magnitude to tell. I mean, say this is number is 5. So 5 bits are enough. I have only 4. So to make this as 5 bits, I will just add 0 here. So now this is called 5. But is this positive or negative? I have 6 bits. 1 bit, this MSB bit here is for sign. Okay, to say which sign. If I wanted it to write it as a minus 5, then I'll make here as 1. If I want it to be written as plus 5, then I'll make this as 0. Okay, when I write 0, 0, 0, 1, 0, 1, that means this is plus 5. See, here he has given this is for sign representation. So 0 means positive number. If in case of 0, if I write 1, that will be negative number. See, here he mentioned minus 5 means in that MSB bit, out of the 6 bits, 1 MSB bit is equal to 1 to represent a negative sign. I mean to represent 1, which is telling you that it is a negative value. Okay, so in this way you represent a sign. So it can be any number of bits. Okay, but the MSB is preserved for the sign value. Now we'll see the ones complement. So what does ones complement means? In the name itself it is there. It is complementing whatever number you are giving. It is complementing one time. Okay, that is called your ones complement. So how we generally do ones complement is, in case if you have this number, this is your some binary number. Okay, given binary number. Okay, this is normal binary number. I wanted to ones complement of this number. Whenever I want to ones complement, what I do is I just convert 1 to 0 and 0 to 1. So replacing this 1 with 0, this one with 0, this one with 0, then here I have 0. So I should replace zeros with ones. 1 and 1 I'll replace with 0, this 0 I'll replace with 1. So now I can say the ones complement of this number is this. Is that fine? So it is very easy to remember. Whenever you talk about ones complement, you should always replace zeros with 1 and ones with 0. Okay. See, complement each bit. Change ones into zeros and zeros into ones. For example, this was a binary number he has given. So as I showed you an example now, you try to convert this 1 0 0 0. So what will the result of, what will the ones complement of 1 0 0 0 will be? Yes, definitely the answer would be 0 1 1 1. Okay, so this is the ones complement. So how to find a ones complement is, you need to remember just this: replace ones with zeros and zeros with 1. Next you have is twos complement. Now we have already seen what is 1's complement. Okay, replace zeros with 1 and 1's with 0. That was 1's complement. Now what is 2's complement? So whenever you are doing 2's complement, okay, now we are trying to do, this is not 5, this is S. Okay, 2's complement, this was 1's complement. Yeah, when you wanted to do 2's complement, always remember, definitely first you need to do 1's complement first. Okay, 1's complement means replace zeros with 1's and 1's with zeros. Okay, that is the first step of the 2's complement. And second step will be, after doing this you will get a result, right? The 1's complement result, you should add 1 to that 1's complement, then you will get 2's complement. Is that fine? Did you understand what I said? So first they are asking you to convert, same number will take 100 before we have done. That was 2's complement of this number if they ask. Then what we should do is first convert them into 1's complement. This is the 1's complement. After that, here you need to add 1 here too. Okay, so add 1 means definitely we'll add from LSB side, right? So yeah, so add 1 means, so for this 1 plus 1 you will get 0 plus 1 carry, 1 plus 1 you will get 0, 1 carry, 1 plus 1 0, 1 carry, and you will get 1. Is that fine? So now have you seen what did you get? You got 1 0 0 0. So what was here? It was 8. 1 0 0 0 means 8. So when I once complemented, here I got was 7. Whatever I got was 7 here. Okay, this was the value for 7. Next, after this I once complemented, yes, these numbers we'll see later. First see the procedure. Okay, don't get confused. For making a 2's complement, I made this number as 1's complement first, and after adding 1 to 1's complement, and after adding 1 to this 1's complement, I got 2's complement. Now this is called 2's complement of this number. Okay. See, most common scheme of representing negative numbers in computers affords natural arithmetic, no special rules. I'll tell you what, why do we use to represent a negative number in 2's complement notation. Decide upon the number of bits, find the binary representation of positive value in bits, flip all the bits, that means 1s to 0s and vice versa. Next, add 1 to that. Okay, so see, these are the steps whatever I just told you. So decide upon the number of bits, just take the number of bits and find the binary representation of positive value in n bits. Okay, so if they give you any other bits, other format, just write it in number of bits whatever they have given. Next, do make 1's complement, change 1's to 0 and 0 to 1's means doing its 1's complement, and add 1 to that, you will get that. So generally, why do we use this 2's complement is to write a negative number in this computer language, in your machine languages. Okay, so that you can understand. And also for subtraction, generally instead of doing the complicated procedures, we generally follow 2's complement. If in your 2's complement subtraction, once you find if you do direct subtraction, you will have two numbers, right? So when you subtract some number 1 from number 2, okay, so number of bits you have, first number of bits and second number of bits. If you subtract that direct method, if you have bigger bits and all, so instead of getting confused with that borrow and all, by using this 2's complement, what you can do is, the whatever number you want to subtract, that number you can convert it into 2's complement. That means first make it 1's complement, then add 1 to it, then you will get a 2's complement. Then that number can be added to the number from which you want to subtract. Okay, it might be confusing to you all right now, but when we make that session, when in that session you will understand what exactly is 2's complement subtraction. Okay. So is the number that results when we add 1 to is the number that results when we add 1 to the 1's complement. 2's complement is equal to 1's complement plus 1. Okay, so binary number, here he has taken 1 0. See, don't think that the before whatever I did was 1 0 0. For that, whenever I made it as a 1's complement, I got 7. Okay, again when I added 1, I got again a same number. Don't expect you'll always get the same number. Okay, see, you just see this example, you understand clearly. I made a slide very clearly to you for positive and negative numbers. Yeah, see, this is the given binary number. Okay, so I wanted to make 2's complement for this, so we'll do it here. See, 2's complement means first I should do 1's complement, that is 0 0 1, then add 1, so I'll get here 1. See, 0 1 0. See, this and this are not same, so never think, always whenever you do 2's complement you'll again get back the original number. Okay, so this is what your 2's complement number is. 0 1 0 1. This what you have done is addition, you added 1 to this. 0 plus 1 1. Okay, 0 1 0. So if you don't have any numbers here, that means they are zeros. Okay, don't get confused. So now see, now after adding this 1 here, you got 0 1 0 1. Is that fine? That is your 2's complement. See, you have a complementary notation, that means see, conversions between positive and negative numbers are easy. So generally 2's complement we use for this purpose, right? So see how is, see here, I take some positive number, let me take some positive number. Okay, when I make that to a 2's complement, I'll get negative number of that. Is that fine? And when I make the negative number as 2's complement, I get again that positive number. Okay, so in this previous case, see, if you want that in this magnitude range, see this here, this was, if you take this 3-bit number here, this was negative and this was positive what you got. So always this differs, your sign here differs. So whenever you write, you make, if you take a positive number, you get that as, if you make a positive number, take a positive number and do 2's complement to that, you will get a negative number, and you take that negative number and you do 2's complement to that negative number, then you get a positive number. Okay, so for example, see, they have we have just done this, I guess, plus 5. Okay, so plus 5 means we'll first try to convert this. See, plus 5 in binary format he has taken, and he converted all that into ones. See, here he had 0 0 0 1 0 1, so 1 is converted to 0. I mean, first he made 1's complement. Okay, he replaced 1's with 0's and 0's with 1's, then he added 1. Okay, after adding 1, now the whatever we get will be minus 5. Okay, so now when we got this minus 5, see, now when you 2's complement this again, again replace 1's with 0's and 0's with 1's and add 1 to that, again you will get plus 5. Okay, so it's simple addition. If you should first be familiar with the addition, subtraction. Okay, especially addition, subtraction, if you will be familiar with this, all doing all this will be very easy. Also division and multiplication. Okay, these are the basics to go further. So if you do them correctly, then you can easily understand the remaining things whatever we are going to study further. So binary, we learned about binary addition, subtraction, multiplication, division, ones and twos complement of binary number. So see, there are some carry out the following arithmetic operations. So see here the fractional part is also there. I'll just show you the first one, try to solve it by yourself. First is 1 0 1 0 1 1 0. Okay, this number you're adding with this number, right? So you can't write 1 1 0 1 1 0 1 in this way. You can never write that, or else you may think maybe I should start from LSB. So start writing 1 0 1 1.011. You can't even do that. Always remember, this is an integer number they have given. This is the fractional number they have given. So when this is integer number LSB is always this, MSB is this. Okay, after that you have point and zeros. If you wanted to write it in the form of a fractional part, you should add zeros, that's it. So the point you have is here, right? So the exact this point should match, it should be here, it should collide with this. And to left side this 0 will be LSB. So 0 1 1 for this number, this is 0 1 1 you need to write. After 0 you need to write the remaining numbers, that is 1 1 0 1. Is that fine? Now you should add this. You can directly add this, or if you are confused to do that, what you need to do is, you have 4 bits here, so just place zeros here, 4 zeros, and here you have 4 bits here, so just place zeros here. Okay, to the left side in integer part you can add zeros, and to the right side after in fractional part you can add zeros. So that is what I have done. Is that fine? So don't think that seeing this fractional number itself, oh this is such a big procedure, it is very hard tough to do. Don't think that way. Just you should know how to write the orientation. Once you know, you can easily add. Now the addition is very easy. So once you add this, see 1 0, yeah, I said I won't solve and I am solving it to you. So yeah, I'll stop it here, you solve it by yourself. But one more thing I want to say is, see in this you're not getting any carry from here to here, but if you get a carry from this fractional to this part, you can add a carry here. Okay, that doesn't matter, because when you add 0.7 and 0.3, so you will get 1.0, right? So this is being added to your this part, right? So same way even in binary. Okay, 0.7 plus 0.3, that is what you add, right, if you get a carry. So that is what we are doing here. So try to do same way, try to do this as well. So you also have multiplication. Even in multiplication, if they give you decimal, same way what I said for this addition, let it be subtraction, division or multiplication, follow the same orientation how what I said. Okay, and this is division. Okay, so try to solve all these different kind of practice problems. Okay, if you wanted more, just replace 1 and zeros and try to do it. And if you wanted an answer, what you need to do is convert these numbers into decimal. Okay, and try to verify that. So if you keep doing that, you will get more and more practice on that. So we'll end it here. Thank you.